let's undo this exponential equation, right? So what do we have? We have 3 open brackets 9 to the power x minus 2 8 open bracket 3 to the power x plus 9 equal to 0. Okay, so these are exponential functions. So the one thing that you need to think about every time you've got such an equation is look at the parts that are having powers, right? 9 to the power x, 3 to the power x, and think of a way in which you can make them to be identical, right? So when I look at 9, I believe 9 can be written in terms of the other one as 3 to the power what? The power 2, right? So out of this 9 we can put that, and then of course we've got x outside that. So I'll just bring back our 3 there. We've got a 3 in front of 9 to the power x, so we'll have a 3 minus 28, and then again 3 to the power x plus 9 is equal to 0. And so at the next step, we've got 3, and then for some reason, since I want this part to be identical to the other part, let's exchange the 2 and x. We understand multiplication is what? Commutative. Doesn't matter what you start with anyway. That's the idea there. So 3 multiplied by 3, it will now be the power x, and then we'll put the 2 outside, minus 28, and then 3 to the power x plus 9 equal to 0. So since we have the 3 to the power x being common, we can let it be to equal to any letter of our choice other than x. So I usually like using y and p. So in this case I'll use p. We see. Okay, let's use y. It doesn't matter anyway. So 3y. So I've said let my y be equal to 3 to the power x. So y, whether we've got 3 to the power x, we are putting a y. So don't forget there's a 2 there. So let me just even go direct anyway. There's no need to waste time there. So we're going to remain with 3 multiplied by this part we're putting y. Now it's equal to the power 2 minus 28. This part equal is going to be now y doesn't have got a power, so it's the power 1, and then plus 9 equal to 0. Now at this point what you see is we have ended up with a quadratic function, which I know now at this point it's actually very easy for most of you to handle this question. So now be at liberty of pausing the video and trying to answer this as a quadratic function and find the value of x thereafter. So pause the video and just do that. Okay, so it doesn't really matter the method that you use. Okay, you can use a formula, you can use factorization if it's possible, and that's what I prefer in this case. So let's say we're trying to try the factorization method. The product of 3 and 9, that gives us what? 27. The sum is the coefficient of y, so that's a minus 2 8. Factors, what two numbers can we multiply to give us the product and add them to give us the sum? So what numbers? So for the sum and the product to be closer, there has to be a use of a 1. So what if we said negative? Well, in this case most likely we're supposed to work with negative 27 and negative 1, so that if you multiply them they give you positive 27, you add them they give you minus 28. So we're just going to get back our function there and then we'll substitute. So 3y squared. Now the sum is what is going to be represented by factors. Of course the factors, you add the same variable we're working with y, and then minus y for minus 1. plus 9. Now we call it factorization because at this stage, this is now where we get what's common. Okay, we split into two different brackets. For the first part, what's common is 3y, and then remain if y, if we remove 3y. For the other part, 27 divided by 3 is a minus. It's a minus 9, right? And then y, of course, is already part of that. The idea is if you factorize, whatever you have in the brackets multiplied by what is outside should give you what you had beforehand, right? And then of course, if you look at the other one, we want to ensure that whatever we're going to have in the brackets should match. So let's pull out the negative so that our y, negative y becomes y, and then our 9 becomes a minus 9, matching up with the first part, equal to 0. And then we can get the factor, which is y minus 9, it's a common part, and then we'll just get the 3y minus 1. It's kind of like I'm teaching factorization method, but I believe most of you already know it. So equate this to 0, so y minus 9 is equal to 0, giving us y is equal to 9 for the first case. And then the other case, we can just say let our 3y minus 1 be equal to 0 as well. So what is that equal to? So our 3y is equal to 1, y becomes 1 over 3. So now that we found the two answers, the two possible values of y, let's try to see if we can help us find the value of x, because that is our interest, right? So the two values that we found are these two. So let's start with the 9. So remember, this is what we said. We said let our y represent 3 to the power x. And so for the first part, if we say 9 is equal to 3 to the power x, I'm getting that value there. Remember how to solve these indices, right? Ensure that the bases are the same. So 9 can be expressed as 3 to the power 2. Okay, so the answer there, x is possibly equal to 2. Then the other one, we have our y being equal to 1 over 3. So 1 over 3 is equal to 3 to the power x. Now 1 over any number can be represented as that number raised to the power negative 1. Okay, so this is equal to 3 to the power x. X becomes negative 1. Okay, so since in this question we didn't have any restriction, the question was just saying solve. It didn't specify find the positive answer or negative, so both answers stand. Okay, and it's actually something interesting that you can try even at your own time. Just try substituting in the given equation there and you see what you're going to have. I want to work with smaller numbers, so I can try negative 1. 3 9 to the power negative 1. 9 to the power negative 1 means 1 over 9. And then minus 28. 3 raised to the power negative 1 is the same as 1 over 3. And then plus 9, and that is equal to 0. So 3, there it's 1, there it's 2. So you have half. No, actually 3 into 9 is 3 times as well. 3 into 3 is 1, 3 into 9 is 3. So you have 1/3. 3 there, 1. 3 into 28 is how many times? I don't think that's possible, because 3 can be divided into 27 9 times. So that will remain minus 28 over 3, and then plus 9. And then come up with a common denominator. Common denominator, of course, is a 3. 3 there, it's 1. That fits 3. And then minus 28. And then 1 into 3 is 3. 3 times 9 is 27. So negative 28, and so we've got a negative there. 1 minus 28 plus 27, that gives us is 0, right? Over 3, that's a 0. So that proves negative 1 is a possible solution. And this is just for fun. It's not a requirement when you're given such a question.